What we're going to take a look at here is the base idea that we talked about the other day when we were looking at the relationship between logs and exponentials. We have to have an understanding that they are inverses of one another. I know I said that a few times in class. You guys are going to have to know that. All right, I'm going to be asking you guys all the time in class, what's the relationship between logs and exponentials? What I mean by that is they're inverses of one another. Now, by definition, an inverse, from what we looked at last chapter, what that should tell me is if I compose the two functions, if I do f of g of x, and if I do g of f of x, I should have a final answer of just x. Alright, so what we're going to say here, hypothetically, we're going to have some f of x be equal to b to the x, and we're going to have some g to the x be log base b of x. So if I went through and I did f of g of x here, that means I would be plugging log base b of x into the function f, which would give me this, log base b of x. Okay, and just by rule, what that's telling me is this should reduce all the way down to x. How that does is because I have an exponent and a log with the same base attached to one another. Okay, that's how it's always going to be. Just like when I have addition and subtraction being inverse operations of each other, or multiplication and division, exponentials and logarithms are inverses of each other, so they're going to cancel each other out. Same idea if I look at this over here. If I have log base b of b to the x, when I look at this should reduce to just x by definition of inverses. How that does is because I have a log base b and the base of an exponential both being the same number. Same thing here, okay? The base of the exponential and the base of the log are the same base. Okay, and the one on the right over here, we can really think about this just like one of those homework questions. B to what power gives me b to the x? The only way that's going to be true is if this is equal to x. The only thing that's going to, whatever our x value is, those exponents got to be the same. It ends up kind of just canceling that out. And we can see that using the swoop-de-loop here. Just a few things, simplifying. So just a few more practice problems with this. If I look at A, I have 3, and then in the exponent I have log base 3 of x. Looking at this, what I notice is I have a base of the exponent and base of the log being the same thing. They should cancel each other out, and I should reduce to just x. Alright, that's how it's always going to be, and we're going to have to do that a lot. And really on the next few slides you'll see how we end up using that. But for these next two, if I look at B, my problem is here, right now I don't have the same base. I have a 3 and I have a 9. So I got to manipulate this a little bit. I'm going to say log base 3, I'm going to change the 9 to be 3 squared. Okay, so if I go through and I do all of this, log base 3 to the 2x. Now if I look at this, really what I could use is the swoop-de-loop. I could say 3 to what power gives me 3 to the 2x. The only thing that's going to make that true is 2x. Now, if you want to look at it a little bit quicker, I can just say, well, I have the same base in my log as I do in my exponent that are attached to one another. Those are going to cancel, and I'm just going to be left over with the 2x, even though it won't be in the exponent anymore. It'll kind of move down. And if that doesn't really make sense, think about it in the swoop-de-loop method. Last but not least, log of 100x. What we have to remember, this is the common log, so that's assumed to be log base 10. And just like I did in the last one, I'm going to have to manipulate this a little bit. I'm going to have to say this is really 10 squared to the x. Same idea in the last one. What I'm going to look at is 10 to what power gives me 10 to the 2x. That's always what I want to think about when I'm looking at logarithmic form in swoop-de-loop. Swoop-de-loop. Alright, so I would look at that, and I would say 10 to what power gives me 10 to the 2x would be 2x. Same idea as if I canceled those two bases out, it would just give me 2x there. That principle, those kind of going through and actually doing that is going to be very important when we look at this next few slides when I'm finding inverses. Okay, because now I'm going to find the inverses of these functions. They're all going to be either exponential functions or they're going to be logarithmic functions. So looking at these ones, these end up being all logarithmic functions. So we're going to have to take a look at an exponential function as well. Now, if I look at A, the first step when I'm finding the inverse, remember, is I switch x and y. So I'm going to change x and y's location. That's the first thing I do, switch x and y. Now, what I want to do is I want to get y by itself. In the past, if I had something like y plus 2, I would subtract 2 on both sides because addition and subtraction are inverse operations of each other. If I had y equals, 2y equals x, I would divide each side by 2 because multiplication and division are inverse operations. Same thing with polynomials and radical functions. Those are inverse operations of one another. Now what I'm going to have to go through and do is I have a log, I'm going to have to pull an exponential function into this. I'm going to have to make an exponential function in this. How I'm going to do that is I'm going to, exponentiate each side, we'll say. All right, so if I go 3 to the x, and then I say 3 to the log base 3 of y, the reason why I do that is because on the right-hand side now, I'm trying to get y by itself, I have a base 3 in the log and the exponential function. So those two are going to cancel each other out, and I'd be left with just y. So if I look at that, I'd have 3 to the x equals y. Now, if you go into Desmos and you graph both of these two things, you should see that they are mirror images of each other across the line y equals x. Okay, so those would be inverses of one another. This function and log base 3 of x. All right, again, I'm going to go through the same exact process for these other ones. Y equals ln of x plus 1. The very first thing I want to do is exchange the place of x and y. So I'm going to do that here. Switch x and y. Now, on that right-hand side, I'm working outside in. When I go through and I do that, looking at this right now, I have a logarithm. I want to bring in an exponential function. And I want that exponential function to have the same base as this log. So looking at that, when it says ln, remember that's the natural log, that would be base e. So what I want to end up going through and doing is bring this number e into this. Remember, e is that 2.718, yada, 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 the rest of it. So I'm going to exponentiate this. I'm going to go e to the x on the left-hand side, and I'm going to say e to the ln of y plus 1 on the right-hand side. The purpose behind that, what that's going to do is the ln and the e will cancel one another out. I would be left with y plus 1. That's going to be equal to e to the x. Now it just comes back to algebra, and we subtract the 1 back over. I'd have e to the x minus 1, because that's what I want to do on both sides here. That got me the y by itself with this. Last but not least, same exact idea. Switch x and y. I have log base 1/3 of y. Same exact approach here. I'm going to bring in an exponential function because I have a logarithmic function. So I'm going to say, well, I have a base 1/3 here. I want the base of my exponential function to be 1/3 for both of these. The purpose behind that, 1/3 here, 1/3 in the base of the exponent. Those two cancel. I would just have y equals 1/3 to the x. That's the basis behind this. All right, same idea. You're switching x and y for the inverse, but now you're just bringing in a different component of it. You're bringing in exponentials and logs and their relationship with one another and how they're inverses of one another. Okay, so now what I'm going to do, obviously you guys don't have to go through and try this. You're going to have your own problems to do that. Okay, so actually, let me change. I'm going to add a c. Alright, let's try y equals 2 to the x plus 1. Alright, so with these three, let's just go through part C. And then I want you guys to try A and B. And I'm kind of going all backwards. Part C, now I have an exponential function. But I'm going to really go through the same process. Switch x and y. Switch x first, I would have 2 to the y plus 1. Just like in the past when we were looking for inverses, work outside in, subtract the 1 on both sides first. I would have x minus 1 equals 2 to the y. Now my issue is I have 2 to the y. So I have an exponential function. I need to pull in a logarithmic function. And I want the bases to be the same. So what I should do is I should take log base 2 of both sides. Take log base 2 of 2 to the y. Log base 2 of x minus 1. This is all going to be within the logarithm. That's just, I'm taking the log of the whole side, not just one piece of it. Alright, those will be equal to one another. Now, just like in the past, log base 2 and base 2 of an exponent are going to cancel one another out. So I would have y equals log base 2 of x minus 1. The same exact idea. When I have an exponential function, I need to pull in a logarithmic function. When I have a logarithmic function, I need to pull in an exponential function. Okay, so what I want you guys to do, besides that C, I'm going to add D in here. All right, so what I want you to do is I want you to find the inverses of the 3 that I'm going to have right here for you. So I'm going to have e to the x plus 2, the x plus 2 and the x plus 2. All right, so what I want you to do, pause the video. All right, pause the video, go through, try these 3, and then after, really check your work with what I go through and do. You know, give it a few seconds, and then come back. So if I take a look at what I got here, I know it's kind of messy with all the work, but try to navigate through it for these few questions. In part A, if you just kind of take a look at it, even if you pause it, kind of look at it a little bit slower. Switch x and y. I have an exponential, I have a logarithmic function with base e, so I'm going to make an exponential with base e. So I go through, and that's what I did here. Okay, I went through and I did that. The e and the ln cancel, and then I would add the 3 to get the y by itself. Same idea in B. So I know I'm kind of bouncing around a little bit. Same idea, I have a logarithmic function. I need to pull in an exponential function. So I have base 10 here, because remember, common log is going to be base 10. So I would do go 10 to both sides. I'm exponentiating each side, right? 10 is the base, to whatever was on both sides. I go through and I would simplify the rest there. Then I have part D in the middle. I have an exponential function. I want to pull in a logarithmic function. That's what I go through and I end up doing here. All right, to practice kind of these, you're going to look at a few other questions. Now, I know you may have questions on this stuff, so what that means is tomorrow in class, what we'll end up doing is we can talk about any questions that we have and iron any of these things out. Good thing I'm done. No need for the low battery.